All right, today we're going to lay out the ultimate blueprint for what might just be the most underestimated tool in all of programming, the humble array. Seriously, mastering this is the key to unlocking your true potential as a coder. So I'm sure you've heard it before. Arrays, oh, that's basic stuff. Just get through it and move on. But what if I told you that thinking they're basic is probably the single biggest mistake holding you back? Trust me, having a weak foundation here can absolutely crush your confidence when you start tackling the really complex problems.
Because you see, arrays aren't just a starting point. They are the foundation. That neat, ordered, predictable structure is exactly what makes all those advanced interview-winning techniques possible. Things like two-pointers, sliding window, prefix sum, even binary search, they all depend on this. Get this right, and I promise everything else just starts to click into place.
So what is it that gives arrays this superpower? Well, the answer isn't in the fancy code you write, but way down deep in the computer's memory. So let's pull back the curtain and look at the memory blueprint that makes arrays so ridiculously efficient. The secret sauce, the magic ingredient, is something called contiguous memory. I want you to picture a row of perfectly connected boxes, all lined up one after the other. That's pretty much what an array looks like in your computer's memory. Every single element is sitting right next to its neighbors, with absolutely zero space in between. And this perfect, unbroken chain is the key to everything.
And because of this perfect layout, the computer can pull off a kind of magic trick. To find any element, it doesn't have to search around. Nope, it just does a little bit of super simple math. It takes the starting point of the array, that's the base address, and just adds the index you want multiplied by how big each element is. And boom, it gets the exact location instantly.
And this little bit of math is the whole reason we get this beautiful result, O of 1, or constant time access. Now that's just a fancy way of saying that grabbing any element from an array is instantaneous. It doesn't matter if you want the very first element or the millionth one, the time it takes is exactly the same. It's just incredibly fast.
But, there's always a catch, right? This perfect, rigid order comes with a trade-off. While reading data is lightning fast, changing the array's structure is, well, it's slow. If you want to insert a new element right in the middle, you can't just squeeze it in. Oh no. You have to take every single element after that spot and shift it down one by one to make room. That stiffness, that rigidity, that's the price we pay for that amazing O of 1 speed. So this whole trade-off thing leads us to a really important decision we have to make. What kind of array do we actually need? There are two main flavors, static and dynamic, and picking the right one for the job is key. So let's break down the difference. Okay, so a static array's size is locked in the moment you write the code. It lives on what's called the stack. Think of it as a small, super organized, and very, very fast part of memory. A dynamic array, on the other hand, can grow or shrink whenever you need it to. It lives on the heap, which is a much larger, more flexible, but slightly slower pool of memory. So the choice is pretty simple. If you know the exact size you need from the start, a static array is going to be faster. But if you have no idea, you absolutely need the flexibility of a dynamic one. All right, that's enough theory for now. Let's see how all this understanding actually helps us write cleaner, more efficient code. We're going to look at a classic problem, reversing an array without creating a whole new one or using up extra memory. This right here is the two-pointer technique in its purest, most elegant form. You just put one pointer at the very beginning and another at the very end. Then you just swap the two elements they're pointing at. After the swap, you move both pointers one step closer to the middle. They just keep swapping and walking towards each other until they finally meet. It's simple, it's super efficient, and it modifies the array directly. No mess, no fuss. Understanding how to use arrays is great, but knowing how to avoid breaking them, that's what builds real solid confidence. So let's dive into the most common pitfalls, the silly mistakes that trip up just about everyone at some point. Yes. Does this look familiar? This infamous, terrifying error is just the computer's way of screaming, hey, you tried to touch memory that doesn't belong to you. And when you're working with arrays, this almost always means you've misunderstood their boundaries. So what are the usual suspects? Well, it's almost always a tiny little slip-up in your logic. That classic off by one error in a loop, like using less than or equal to the size when you really just meant less than. Or, and we've all done this, just forgetting that if an array has 10 elements, its last box is numbered 9, not 10. These small, innocent-looking mistakes are what lead to that big, scary error message. So here it is,
the one rule you absolutely must burn into your memory. The golden rule. For an array of size n, the only valid spots you can touch are from index 0 all the way up to n-1. That's it. Anything outside that range is completely off limits. Internalize this one rule, and I promise you'll avoid a world of pain.
And you know, that really brings us to the heart of it all. Becoming an expert programmer isn't about memorizing hundreds of super complex algorithms. Not at all. It's about having a deep, intuitive, rock-solid understanding of the fundamentals. Just like this blueprint for arrays we've talked about. This foundation, this is what lets you build everything else. So there you have it. You've got the blueprint now. You understand how arrays really work under the hood, you know their trade-offs, and you know how to handle them with confidence. So the only question left is, now that you have it, what are you going to build with it?